today's lecture. I think this is the fourth part of chapter 6, Deep Foundation. First part was introduction, general idea about what are piles and how they are constructed and so on. In part 2, we studied the first method to solve piles using an equation that is given in the Egyptian code. This equation depends on two parts, part for the bearing and bearing of the pile and part for the friction of the pile, and we said that this is limited to piles that are less than 60 centimeters. The third part of our lecture, we used a different approach. This different approach depends on, it is for piles that are with diameter more than 60 centimeters, equal or more than 60 centimeters, and it depends on drawing charts and getting values from the charts to solve the problem. Today's lecture is the third method for designing the piles. We said that we took one for diameter less than 60, and the other for diameter more than 60. Now we are going to study another method that is mainly dedicated for any diameter of piles, but for piles that are constructed by driving. It's not board piles. So the main equation of this, for the design equation, is based on what we call dynamic formula. The dynamic formula, it is similar to our SPT test. In SPT, we use a dynamic method because SPT is a dynamic operation. So this method is based on this dynamic operation, and it is also better simulating dynamic construction of piles, which is driving the piles itself. This method is very straightforward. It is given in the Egyptian code. These are parts of the Egyptian codes, and this is the translation of these sections. We are going to discuss it now in details. I just need to show you the equation first. This is the equation. This is the equation given by the Egyptian code. First thing I want you to notice is that the equation says that this is Q allowable. If you remember, in the other methods, this one, it was Q ultimate. So the first difference, the first method, it was giving Q ultimate for the pile. The second method, which is the drawing, we are drawing a curve till reaching failure. So it is also the ultimate. So it also deals with the ultimate. In this method, the equation gives you directly the allowable. So please remember this it's very important, because you don't get a number and divide it by the factor of safety, because it is already divided by the factor of safety. This is one thing. This equation is divided into two parts, similar to this one. This one was also divided into two parts, part for the friction and part for the end bearing. So here it should be the same, part for the friction and part for the end bearing. Which part will be the friction and which part is the end bearing? We know it from the area that we are using. In this part of the equation, we are multiplying 90n, we'll discuss what is n, and here is n bar. We'll discuss also what is n bar. But this is multiplied by pi r squared. Pi r squared means the area of the pile. The area of any circle is pi r squared. So pi r squared is the area of the pile. The other term is 2 pi r multiplied by L. 2 pi r, this is the circumference, multiplied by L, it means the surface area. So from the first look, you will know which is end bearing and which is friction. Friction uses which area? The sides, the area of the sides. End bearing uses the cross section of the pile. So this is the part that gives you the value of the end bearing. And this is the part that gives you the value of the friction. Similar to this one, I have here part for end bearing multiplied by the area of the pile, part for the friction multiplied by the area of the sides of the pile. So they are similar in this way. But here there is a factor of safety that is already included in the equation to give me direct the Q allowable. If you check the Egyptian code, you will see that here they are saying that this given value includes a factor of safety of 2.5 for the friction, for the end bearing, and 2 for the friction. You will see the translation above. It should be somewhere here. No, it is not here. Then I'll just say it here. Here, this is very, very important. I can add it by hand here, that the factor of safety for the end bearing is 2.5, and the factor of safety for the friction is 2. So here there is a difference between the factor of safety of the end bearing and the difference between the factor of safety of the friction. In other equations similar to this one, usually when I get Q ultimate, to reach the allowable, I divide by one value for the sum of friction and end bearing. So in this equation, they do not differentiate between end bearing and friction. But in this equation, there is a difference between the factor of safety for end bearing and the factor of safety of the friction. So if I tell you, use this equation, so you are going to get Q allowable. If I tell you, what was the ultimate of friction and the ultimate of end bearing, what should you do? Each, yes, this is very correct. You multiply, you will calculate this term, and you will see what is this term. This is the term for end bearing. What is the factor of safety of end bearing? It was 2.5. So I will multiply here by 2.5, and the other one I will multiply by 2. So if I want to write this equation again, I will say Q ultimate equal 2.5 multiplied by 90 and so on, plus 2 multiplied by n bar and so on. So now you can get from this equation the ultimate and the allowable. But the allowable, to reach the allowable, you have to use each factor of safety as given in the code. So this is the first thing I want to concentrate on. Let's see what are the terms here in this equation. Yes, it is written. The factor of safety is written here. Yeah, I thought it should be here, but it was in the next slide. No, it's okay. So this is what we need. There is something in the equation called n, and there is something called n bar. N and n bar, from the name n, what is n? We said that this is a dynamic and it depends on the SPT. And in SPT we have n. What is n value? What is n value? You remember SPT test, what we get out of this test? We measure the number of blows for the first 15 centimeter, and then for the second 15 centimeter, and then for the third 15 centimeter, and I sum together the second and third portions. This is the end value. So usually, if I have, I should see here, yes, this is this graph. This is the pile, and this a graphical representation of the n values that was measured in site investigation. It has nothing to do with the pile. This is during site investigation, they made few boreholes. In these boreholes, at a depth of 2 meters, the number of blows, the total number of blows was 3. So this is the n value. At 4 meters, it was 5. At 6 meters, it was 6, and so on till you reach 20, it was 24, and so on. Maybe they reached 50 meters. It was not mainly dedicated for the design of piles. They are just doing SPT tests in boreholes, that's all. So we take these, we put them next to our pile. Our pile starts, say, from a level of 2 till a level of 18. How to calculate n and how to calculate n bar? N bar is used for the term of, let's see again here, n bar is multiplied by 2 pi RL, so it is for the friction. So the friction of the pile starts from here till there. It means that all of these n values affect the friction. Here it affects this portion, here it affects this portion, and so on till you reach the bottom. So n bar is the average. You start with the tip of the start of the pile, here is a value. This is the end of the pile, here is another value. All the values in between will be summed together. This is the summation of all of the values within the pile length. Anything above or anything below, I don't need. Okay? So I will take all of these numbers, divide them by the number of how many? 1, 2, 3, 4, 5, 9. Okay, so this is 9. Then this is 10.9. So 10.9 is the n bar, which is the average value of SPT values along the side of the pile. Now I need n. This n will be used for end bearing. So it only operates here at this pile tip. But it will be a very strange coincidence that at this point I have a value. I may have a value above or sometimes below. So they tell me in this equation, from the pile tip, go below 1 diameter, 1 pile diameter, and go up 3 pile diameters. And any values in between these dotted lines, take the average of them. So this is the area that will affect the end bearing. This is the only area that, if I have a number here, it will not affect the end bearing. It's very far away. If I have a number below here, it's very below, far below. I don't want it. I just want anything that is here. So by coincidence, we only have one value here. But we might have 2, we might have 3, who knows? It depends on your pile diameter and the distance between the SPT values. So in this it is 21, so you will find that it is given that n will be equal to 21. Where is it? Maybe it is in the previous, anyway, you will find, yes, here, n is 21. So n is 21, which is this value. As I told you, if you have another number here, which is 20, so you will take 20 plus 21 divided by 2. If you have 3 numbers, it will be divided by 3. So this will be used for this n will be used for the end bearing, and n bar will be used for the friction. Now, I have both values. What is remaining? Remaining is pi and r and l. These are the pile dimensions. So this is very, very trivial solution. It's nothing. N values multiplied by pile dimensions. That's all. I substitute in the equation, I will get a number. Anyone remembers what is this number? Is it allowable or ultimate? Here, if I put all the numbers in the equation, what I'm going to get? Allowable. This. Pardon?
I'll add the 2 and the 2.5 of the factor of safety, then I can get the ultimate.
You will add the 2. If you need, if by chance you need the ultimate for any reason, then you will have to take each term and multiply it by its corresponding factor of safety. This is as I told you in this example, we have many things that I want to stress on it. The last thing I want to stress on it is that this equation is mainly used for driven piles. So suppose I want to use it for board piles. What should I do? The Egyptian code stated that in case of board piles, the actual values for board piles or the corresponding values for board piles may be 50 to 100% of the values that you are going to get. So this equation is used for driven piles. But if I want to get the Q allowable of board piles, then I should take this number, divide it by 2, or maybe not divide it by 2, take it as it is. It depends on the case, because not all board piles are the same. There are types of board piles that are very, very good, as we said, according to the method of installation of the pile or construction of the pile. If you are using a casing, and then your piles will be very good. But if you are using CFA, or it depends on your method of the construction. So I will take, I don't want to take risk. So what I'm going to do, if I calculate Q allowable using this equation, and it gives me the value for the driven piles, if somebody tell me what would a similar pile, but that it was constructed as board pile, what will be the value? I will take half of this value to be in the safe side. It may be more than half, but I will not go to more than that. So if you calculate, so if you have if I tell you in a question, you have a board pile with the following dimensions, and use this equation, this dynamic formula, to calculate the capacity of this pile, the Q allowable of this pile. You will use the equation, and then when you finish, you said that this is for driven pile. However, for board piles, I will take half of the value to be in the safe side. So if this pile it can carry 200 ton, then I will only allow it to carry 100 ton in case of being board pile.
So I'll just divide the value that
Yes, the final value I will get divided by 2. So you have here, that's why last lecture I told you I'm not going to continue, because I need to stress on many points. The first point is the difference between the factor of safety here and the factor of safety there, and how to get the allowable and the ultimate. This is the first point. The second point, how to get allowable or ultimate for a case of bored pile or driven pile. So you now have all the data you need to calculate anything, but I think after seeing this, you find that you divide by a value by 2. It means that I'm not very certain in the value of what the pile can carry. It means that if you use different equations, you will get a variety of values. So which value is the correct one? I really don't know. How can I judge which is the correct one? I have to perform a full-scale pile load test on site prior to construction, because I may change my design based on this. Now I design a pile and I tell you that this pile can carry 200 tons. Okay, you will design everything, calculate the dimensions, make the drawings, give it to the contractor. The contractor will go to the site, and before he starts, I will tell him, you have to perform a pile load test at the beginning. He will go outside of the site, next to it, construct a similar pile, and will load this pile, take the chart for the loading and the settlement, and from this, it either proves my design or tell me that my design was not correct. In case I say that the pile can carry 200, and using my design, using my testing results, I found that it will not carry more than 150. Then my design has to be changed again, to have to be changed to be 150, not 200. But suppose I prove that the pile can carry, instead of 200, it can carry 250, I will not change the design, I will keep it as it is. So pile load test is used to prove my design and to reduce it in case I found that my design my piles were over-designed. Yes. Now the question relates to the difference between Q allowable and Q ultimate, and driven pile and board piles. This equation is for Q allowable of driven piles. If I want Q allowable of board piles, then I will divide this total number by 2. Then I will get the value for the board pile. Leave it, okay, suppose that it is driven pile, not board pile, but I want the ultimate load. To get the ultimate load, then I will take this value, multiply it by 2.5, and I will take this value, multiply it by 2, add the sum, it will give me Q allowable of Q ultimate of this type of pile, which is the driven pile. If once you get it, I tell you, no, I want the Q ultimate of board pile. So you will take the number that resulted from multiplying this by 2.5 plus this by 2, and take the sum, divide it again by 2 to get the multiply it by 2 to get the ultimate load. And not divided by 2 to get the ultimate load of the board pile. Okay, it's a little bit confusing, but you have to understand. There is a difference between the effect of the type of installation of the pile or the type of construction of the pile, and the effect of the factor of safety on end bearing and friction. These are the two. We'll just, I think we will have here a test. This is an example. what is given? He is giving you the length of the pile, the diameter of the pile, the length of the pile, the start, the depth of the pile cap, and the SPT values. Of course, this SPT values start from 2 meters till 24 meters, but my pile is not 24 meters. It will end up, say, here at 18 meters. So all of these numbers are not important for me. What is important are the values within this range. So I will just draw these values next to my pile. My pile is diameter is 0.5. It starts from a depth of 2 meters, and the length of the pile is 16 meters. I will just first calculate n. What is the value of n? We said that n is the value for the end bearing. So I go to this end of the pile, go down 1 diameter, go up 3 diameters, check whatever numbers I have here. If I have 1 number, I will take it. 2 numbers, I will take the average, and so on. N bar, I take the pile start and pile end. I go horizontally. Whatever numbers I see in front me, I will add them together, divide them by the number of values to get n bar. Then I will go to the equation. I will just substitute in the equation using the length, which is 16, the diameter or the radius, which will be 0.5 divided by 2, which is 0.25, and so on, pi, that's all. I will get Q allowable of this pile. Let's check what was the type of the pile here. Results of geotechnical investigation of a site investigation showed that the subsurface profile consists of deep deposits of so-and-so, groundwater table exists at a depth of so-and-so, below the ground surface, a group of bored piles 50 centimeter, 16 meter long was suggested. For the deep foundation, the site, the foundation level at the bottom of the cap. Estimate the allowable compression capacity of a single pile using both structural formula and in situ results, and so on. Comment on that. So, in this, he did not state what is the type of the pile, but he told you use this equation. So it means that whoever who asked you, he knows that this is the correct equation for this type. But usually in an exam, I will tell you this is bored pile or this is driven pile. If you find that it is a bored pile, then you have to divide the numbers by 2. That's why in this equation you will find that he did not divide the numbers, but he in the next example, he said that in case of drilling piles, bored piles, it means drilling pile means bored piles. In case of bored piles, the pile load will be between 50 to 100%. So we are going to take the 50% and divide by 2. So in this, if I tell you what is the Q allowable, you will take the previous value, which is here 322.5, and I should divide it by 2. Okay. Next thing is the structural capacity. You remember we said something in all methods. What was this? You follow me? We said something. We said that whether we are using method 1, method 2, method 3, all of them gives me what the soil can carry, not what the pile can carry. You have to take this into consideration. We say that this equation gives you the capacity of the pile. This is a wrong expression. It's not the capacity of the pile. It is the capacity of the soil to carry the pile. It means that I have to check another thing. What is the actual capacity of the pile as a structural element or as a concrete section? So I have in all cases, once I finish my calculation, to go to the area of the pile multiplied by FCA to get what the pile can carry. So here the pile can carry 785. The pile can carry a lot. So in this case, I will take the 322.5 as being the number that I should base my design on. So this is how we calculate these values for using the third method. I want to go into another thing very quickly, because it is not something new. I will just tell you what is the capacity. Now we finished the third method. Now we can design any pile, whether board, driven, whatever, ultimate, allowable, whatever you need, you can get. But this is all for, we are considering the friction and the end bearing. It means that we are considering a vertical load on the pile. Suppose it is not a vertical load on the pile, it is vertical but in the opposite direction. It's a tension load. What is the difference between tension load on a pile and compression load on a pile? In compression, friction will work because friction works up or down. And in compression, end bearing will work. But in tension, friction will work, but end bearing will not work. Because end bearing means the pile is bearing on the soil. And you are telling me that you are grabbing it outside of the soil. So it's not based on the soil. It is frictioned by the soil. That's all. So in this case, the only difference, if I tell you in any of these problems, calculate the compression and the tension load. For the compression, you will give me the previous numbers, but for the tension, you will exclude the portion of the end bearing, and you will take the friction only. You see, now we have many combinations. The friction has a different factor of safety than the friction, and the relation between the allowable and the lots of relations. But if you think of it, it's nothing. They are trivial things to think of. So in this case, T ultimate, which is the ultimate tension load, it is only the load due to friction. And the load due to friction, if I use my first equation, then there is something I should, you remember KHT and multiplied by the, and so on. So all of this, I will take only this friction load. And if I have a factor of safety, it will be on the tension load, so it will be on the friction alone.
But however, I calculated the friction, I didn't take the same as the calculation that I did for the friction alone.
No, it is the same. Calculated from any, because we are here just discussing the criteria. The criteria is that I take the friction load only. If I use this method, where is the part for the friction? This is the part for the friction. The part that is multiplied by n bar. This is the part of the friction. So if I tell you use this equation for tension pile, you will only take this part. If I tell you use this equation, here, this one, if I tell you use this method, you will ignore the chart for the bearing. If I tell you use this, whatever the method you are using, it applies for it. So that's why we are not concentrating on which method you are using. Use whatever method you want, or whatever is available for you. But yes, you have to neglect the end bearing portion. So we'll go here. So now I take the ultimate load that is given for tension using any equation. If you are using the equation for the dynamic equation, then you will get directly the allowable, not the ultimate. Here I'm saying that the ultimate divided by the factor of safety. This is the general rule. But if you are using the dynamic formula, you will get directly the allowable, but just ignore the portion of the other portion we don't need. Okay? But you will find that here we added something, the own weight. Why? Because I already lost part. For the tension, for the compression, I have friction and end bearing. So it is a considerable amount. But if I tell you what is the tension, you will tell me the tension is the friction only. What about the end bearing? It was a considerable amount. I lost it. So I need some compensation. What is this compensation? You will tell me, take the own weight. Because the own weight is there and it is existing. And it is always going down. And the tension is going up. So it helps in reducing the tension. So I can take it. And in this case, I'm going to take it without any factor of safety. It's the area of the pile multiplied by the length of the pile multiplied by the unit weight of concrete to get a value. This value, it's not a very big deal. Suppose I have a pile carrying 200 ton and I calculate what is the value of the own weight. Maybe it's 4 ton. 4 ton out of 200 ton. It's not a big deal. But why not? Why not to consider it and to add it to my calculations? So the T allowable will be T ultimate divided by factor of safety, or T allowable if you are using the dynamic formula directly, plus the effect of the own weight because it is there all the time. Yes? As we said, Q friction is the value of the friction multiplied by the area of the sides of the pile. Use any method, but here we have given this method, which is this one, which is the first method. Why? Because if you remember in this first method, we said that to calculate the vertical compression force, we are using a factor called KHC. C here means compression. And if you go to the charts, you will find that in the charts there is something called KHC and something called KHT, which is T for tension. So we are just stressing on the fact, if you are using the first method, don't take the number for friction as it is. You have to change KHT to be KHC to be KHT. But if you are using any other method, use the same value. This is another proof that methods for the design of piles are a little bit not very accurate. The range of application is very big, and here if you are using this method, there is difference between tension and compression. If you are using another method, tension and compression are the same for the case of friction. Why? Because this is their assumptions. In every method, there is assumption. Our assumption here is that there is a difference between tension and compression. But for the other two methods, I don't have any difference in tension and compression. So whatever the method you are using, use it here and then divide it by the factor of safety if you are getting the ultimate. If you are using an equation like the equation for the dynamic formula and it gives you directly the allowable, then use the allowable as it is the portion of the friction only. And as I said now, we are going to add the own weight. Why I'm going to add the own weight without any factor of safety? Because really I don't have any uncertainties. Why do we use factor of safety? I use factor of safety because I'm not sure of my values. But if I tell you what is the own weight of something, if I tell you what is your weight, and you go on a very accurate balance, you measure your weight very accurate, and you tell me my weight is 75 kilos. Okay, it is 75 kilos. There is no possibility if the equipment you are using is accurate, then it is your number. But if I tell you what is your height, and I'm using my hands to measure your height, I will tell you it may be, and it may be so and so, and it may be so. There is some uncertainty, but in measuring the own weight, I don't have any uncertainties. I know it is the own weight. I even take the own weight, I use the minimum cross section. I don't maybe piles, I say that the diameter of pile is 1 meter, but maybe during construction it is 105 meters. Maybe in portion the pile bulged a little bit, the concrete bulged a little bit in some layers. So actually the own weight of the pile will be more than that. So what you are using is the minimum weight for the pile that will exist, so you don't have to take any factor of safety on this number. A very quick example. يعني we are not going to study it in details, but I have 3 layers similar to my previous example, and I have C and phi for all of the layers, and I tell you use the calculate the tension load. To calculate the tension load, as we said, that I will use this portion, which is, I will use here KHC. I should use, if I'm using, I'm calculating the compression load, then I will use KHC. If I am calculating the tension load, then I should use KHT. That's all. The difference will be, considering the big differences we have between different methods, the difference between KHC and KHT will not be that big, but this is what what they say, so we have to follow what they are giving. So I think in this case they are calculating as I remember, this is how we calculate the compression force, and then repeating the same for the tension load. In this case, I should change and use here KHC, and in the other one I should use KHT, and then they compare both results. I need to show you where is KHT. You can check it from the when you go into the calculation. Just check it to see where it is KHT, because maybe it is just misprinted. Maybe here it should be KHT, not KHC. But anyway, you know what we need to say. We need to say that to calculate the tension load of the pile, I use the friction regardless of the method that I'm using. If I'm using a method that do not differentiate between tension and compression, then use the value divided by the factor of safety if you have the ultimate to get the allowable, then add the own weight of the pile. This is the tension load of the pile. Compare it to the compression load of the pile, it will be the friction plus the end bearing. So compression means friction plus end bearing, tension means friction plus own weight. That's all for this method. Next lecture we will, now we finished how to design different piles. The remaining would be piles under horizontal load, piles in groups, settlement of piles. These will be issues that we will discuss in the coming lectures, inshallah. Thank you and see you next week.